All right, so this is the active filters lab. So here we have the circuit. This first one is a low pass filter. So we have our op amp chip here, and then here we have the resistor and the resistor that create the ratio for the maximum gain, as well as the capacitor here that makes it an active filter. And so the signal is going in, and then as you can see here from our gain plot, the blue is the output and the yellow is the input. At these lower frequencies here on this side, there's an amplification due to the ratio of the resistors. However, at higher frequencies, the signal becomes attenuated because the capacitor starts acting more like a short circuit. And then the phase response here, you can see at lower frequencies it's out of phase negative 180, and then in the middle it's out of phase positive 180, and then it slowly drops off at very high frequencies. So then for the high pass filter, we again have a capacitor. This time it's in front of the first resistor, and that resistor then is going into the negative terminal, and then another resistor is providing negative feedback with the output. And so that has this gain response. So at low frequencies now, the signal is attenuated here. And then at high frequencies, you get the gain based on the maximum potential, which is the ratio of the resistors. And then the phase response here, we have it's kind of out of phase negative, and then in the middle it's completely out of phase negative 180, and then it switches to positive 180. And so then when we cascade them, we are essentially just connecting the output of the first low pass filter into the input of the high pass filter, and what that does is create this response. So it's basically just putting them on top of each other. So at low frequencies the signal is attenuated because the high pass filter does that. In the center, neither of them attenuates it, so you get all the gain, and this time the gain is multiplied. You multiply the gain of each circuit together, so the ratios that we had before are now multiplied. So we have a higher gain, and then the signal is attenuated at the end because of the low pass filter. And then you can see this phase response is also just an addition of the two phase responses, because in the beginning here, there's more. If you add these two phase responses from the low pass and high pass filter, you get slightly positive, but then in the middle where they directly cancel, because one was out of phase negative 180 and one was out of phase positive 180, they completely cancel and you're in phase here. And then at high frequencies it is out of phase in the negative direction. And then we also see the 3 dB frequencies are basically just being put together here. So for the low pass filter, the 3 dB frequency is about here, which is about 20 kilohertz. And then for the high pass filter, it's at about 20 kilohertz. And then here we see for the cascaded, again, the minus 3 dB frequency on the left side of the maximum is at about 20 hertz, and on the right side of the maximum it's about 20 kHz.